Alright, today's lesson will be over vertex form. Our objectives for this lesson are to understand vertex form, to understand what roots are, and to understand graphing quadratics. Our vocabulary needed for this lesson are roots. This is when f of x equals 0. This is really just another name for x-intercepts. The line of symmetry. This is a line through the vertex that cuts a parabola into two mirror images. And finally, vertex form. This is a form of y equals a times the difference of x and h squared plus k, where the vertex is known as hk. Let's first take a closer look at exactly what vertex form is. Here's that form that I just spoke of in the vocabulary. The vertex is the point hk within the equation. And for our purposes, we're going to focus mainly on a values of 1, meaning that this a will not be in it. We could put a 1 in there, but we don't need it. One of the catching points is the minus sign in front of h. What this means is, if h is positive, you will see a subtraction sign in front of it. If h is negative, you will see a plus sign because you'll be minusing a negative. K is more straightforward as it has a plus sign in front of it. So if you see a positive k, that means that k is actually positive. And if you see a minus sign in front of it, that means that k is actually negative. So let's get into how this works from a graph and how to create vertex form. We'll start with a basic quadratic formula, or quadratic equation, that is. And we're going to graph it. So we're going to go through the process of finding all these points so we can graph it, find the vertex, and create vertex form. So I've got 0 as negative 3. I'm going to go through this process for each of my x values. This time we get negative 6. Negative 7 for 2. Negative 6 again for 3. And negative 3 again for 4. So now we're going to graph this and look at what we have. 0 was at negative 3. 1 was at negative 6. 2 was at negative 7. 3 was at negative 6. And 4 was at negative 3. We now have a graph of a parabola. One of the things that we can use from this graph is the line of symmetry. Right through this vertex is a vertical line that cuts it in half. Since the vertex goes through an x value of 2, the line of symmetry is just x equals 2. So this is our line of symmetry. our vertex is at the point 2, -7, meaning that's what we will use when we create vertex form. Vertex form looks like y equals a x minus h squared plus k. We know that the vertex of our equation that we just worked with is 2, -7. So all we do here is we take the 2 and we put it in for h. We take the -7 and we put it in for k. Because we're adding a negative here, we would just turn this into subtraction. And we now have vertex form of an equation. But we still have that a. Well, we've been talking about using an a value of 1, so we can get rid of it, or we can put a 1 in there. This is a useful equation because we can now find the roots using this vertex form. If you remember from the graph, we have roots somewhere between 4 and 5 and somewhere around -1. But I'm not comfortable giving an exact answer for those using the graph. So we can use vertex form, which is what we've done in the past. This equation is the one that we just came up with. If we want roots, all we have to do is take the y out and put a 0 in. From our past experience, we should know how to solve an equation like this. We can add 7 to both sides. We can square root. Remember, when you square root, you get 2 possibilities. Since this is not a perfect square, we will have a positive square root of 7 equals x minus 2, and a negative square root of 7 equals x minus 2. We're going to add 2 to both sides of both problems and come away with an x value of square root of 7 plus 2 and an x value of negative square root of 7 plus 2. These would be the x values of our roots. Thank you, and remember, if there's any of this that you didn't catch or that you need to look more closely at, please pause the video, go back, and rewatch it. Thank you.